All right, welcome to another deep dive today. We're diving into social choice theory, which, I think for philosophers is a pretty interesting topic. It's basically how do you get from all these individuals and their beliefs and values and whatever to a group decision. And this is a problem that's existed in political philosophy for a really long time.
Yeah, and I think especially for philosophers who are really interested in this question of how do we form a we, right?
Yeah.
How do we get from all of these individuals to a collective that can make decisions? It becomes really important.
Yeah, and it's not even just voting. It's any kind of decision-making process, right? It could be like a jury. It could be like a committee. It could even be like a group of friends trying to figure out where to go to dinner.
That's right.
So, the applications are pretty broad here.
Yeah, it's really about aggregation. How do you aggregate all these different inputs and get some sort of output that reflects that?
So for this deep dive, we're using excerpts from the Stanford Encyclopedia of Philosophy.
Always a good place to start.
Yeah, I think they cover pretty much everything. And so, we're going to try to bring you some of the core ideas and some of the major problems. And I think for philosophers, a lot of this will be pretty intuitive.
Yeah, I think you'll see some connections with ideas that you're already familiar with.
Yeah. So where should we start? This is a massive field. Where do we even begin to understand, the core of social choice theory?
Well, let's start with the folks who actually were some of the first people to think about this in a rigorous way. I think Nicholas de Condorcet and Kenneth Arrow are two really good examples.
Yeah. Condorcet was way back in the 18th century, Enlightenment philosopher. Talk about reason and collective action and stuff like that.
That's right. And so one of the things that he was really interested in was this idea of how groups make decisions. And he had a couple of really important insights.
Yeah, there's the jury theorem,
yeah,
which I think a lot of people are familiar with.
Yeah.
And then there's Condorcet's paradox.
Mm-hmm. Yeah, so the jury theorem, I think, is something that's been still very popular, right? It's this idea that if you have a bunch of people and each of them has a slightly better than random chance of being correct, then if they vote, the majority is going to be more likely to be correct.
Yeah, and it's if you add more people, it just gets more and more likely that they're going to get the right answer.
Right. So you can imagine a jury, right?
Yeah.
And if each of those jurors has a slightly better than random chance of saying whether the defendant is guilty or not guilty,
yeah,
then the more jurors you add, the closer you get to certainty that they're going to get the right answer.
Which is interesting, right? Because that almost provides a mathematical justification for democracy, right?
Yeah.
If individuals, are competent and if they're independent in their judgments, then the more people you add, the better the decision making is going to be.
That's right. Yeah, this is what some people would call an epistemic argument for democracy, right?
Yeah.
Because it's saying that the majority is more likely to have true beliefs than any one individual.
But that relies on, like you said, two pretty big assumptions.
Yeah.
That people are competent and that they're independent in their judgments, which in the real world, I don't know if that's always the case, right?
Yeah, those are pretty big assumptions. And we can see how that breaks down if you start to relax those. So, for example, let's say that the individuals are less competent.
What if they're only right 50% of the time?
Right, or even worse. Then the more people you add, the more likely it is that they're going to make a mistake.
So, having a larger group actually makes it less likely they're going to get the right answer.
That's right.
Interesting. Okay. And what about independence? That one seems pretty tough to satisfy, too.
Yeah, people are social creatures, right?
Yeah.
We talk to each other, we influence each other. And so it's pretty unlikely that our judgments are ever going to be truly independent.
Yeah, if you're on a jury and everybody's talking about the case and influencing each other, then it's not really 12 independent judgments anymore. It's more some kind of group dynamic going on.
That's right. Yeah, and then you get things like, conformity bias and groupthink and all sorts of other things that can make it hard for people to think independently.
So it seems like the jury theorem, while interesting, is probably pretty limited in its application to real-world scenarios.
Yeah, I think that's fair to say. It gives us some really interesting things to think about. But I think, the real world is always going to be more complicated than any model that we come up with.
Okay. So that's one side of Condorcet. But then he also identified a pretty big problem with majority rule itself.
Right.
Which is Condorcet's paradox. Can you
Yeah.
explain that one?
Yeah, so Condorcet's paradox is the idea that even if each individual has rational preferences, and by rational I mean they can rank the options and those rankings are transitive, right? So if they prefer A to B, and B to C, they prefer A to C.
Like basic logical consistency.
Right. So even if everyone has rational preferences, it's possible for the group to have irrational preferences.
Yeah, how's that possible?
Yeah. So let's say we have three options, A, B, and C. And let's say that a third of the population prefers A to B and B to C. And then another third prefers B to C and C to A. And then the last third prefers C to A and A to B.
Okay, so everybody has a clear ranking of the three options.
Right. But now let's say we have a vote between A and B. What happens?
Well, the people who prefer A to B would win.
Right. 2/3 of the population would prefer A to B. But now, what if we have a vote between B and C?
The people who prefer B to C would win.
Right. And then what if we have a vote between C and A?
The people who prefer C to A would win.
So we have this cycle, right? A beats B, B beats C, and C beats A.
Whoa. So even though all of the individuals have like logically consistent preferences, the group ends up with this like cyclical preference that doesn't make any sense.
Right. That's the paradox.
Which is pretty wild, right? I mean, for philosophers, this really challenges the idea of like a collective will.
Yeah, it undermines the notion of like a rational collective will. Because even if everybody is being rational, the group can still end up being irrational.
Yeah. Like the will of the people as expressed through majority rule might be inherently contradictory.
Yeah.
Okay. So we've got this problem with majority rule.
Right.
And then we have Kenneth Harrow.
Right.
Who I guess was trying to think about this in a more general way, right?
Yeah. So Arrow was really trying to think about like all the different ways you could aggregate preferences. So he said, okay, let's think about a social welfare function. This is just a general term for any way that you can take the preferences of individuals and turn it into a social preference.
Okay.
And he asked, are there any social welfare functions that can satisfy a certain set of pretty basic conditions?
Yeah, I mean, you would think that there would be some pretty simple rules that you could come up with that would be fair and reasonable.
Right. Like, for example, if everybody prefers A to B, then the group should prefer A to B.
Yeah, that seems pretty basic.
Right. Or like, there shouldn't be one person who gets to decide everything.
Yeah, a dictator.
Right. So Errol came up with 5 conditions that he thought were pretty basic, and pretty reasonable for any kind of democratic system.
Okay, what are those 5 conditions?
So the first one is universal domain. And this just means that the social welfare function has to work for any possible set of individual preferences.
Okay, so like no matter what people's preferences are, the system has to be able to handle it.
Right. The second condition is ordering. And this means that the social preference has to be transitive. So if the group prefers A to B and B to C, then it has to prefer A to C.
Okay, so no more of those weird cycles that we saw with Condorcet's paradox.
Right. The third condition is the weak Pareto principle. And that just says if everybody prefers A to B, then the group should also prefer A to B.
Okay, so if everybody agrees on something, then the group should agree on it too.
Right. The fourth condition is independence of irrelevant alternatives.
Ooh, that's a mouthful. What does that one mean?
Yeah, so that one means that if we're comparing A and B, the social preference between A and B should only depend on people's preferences between A and B. It shouldn't depend on their preferences about some other option, C.
Okay, so like if we're trying to decide between pizza and tacos, it shouldn't matter how people feel about hamburgers.
Right. And then the last condition is non-dictatorship, which just means that there shouldn't be one person who always gets their way.
Okay, so all of those seem pretty reasonable. Like, I don't know how you could have a fair and democratic system without those conditions.
Right. But here's the problem. Arrow proved that there is no social welfare function that can satisfy all 5 of those conditions.
Man, seriously.
So, it's literally impossible to have a system that's fair and democratic and also produces, consistent results.
That's essentially what Arrow's theorem says, which is, pretty depressing, right? I mean,
Yeah.
It's what's the point of even trying to make collective decisions if we know that they're always going to be flawed in some way?
Yeah, it can definitely be seen as a pessimistic result.
Yeah,
but I
yeah.
think, it's also a really important insight, right? Because it forces us to think carefully about what trade-offs we're willing to make.
Okay, so, maybe we can't have all 5 of those conditions, but maybe we can relax one of them a little bit and see if we can get something that's, at least good enough.
Right. And a lot of the work that's been done in social choice theory since Arrow has been about exploring those kinds of trade-offs.
Okay, so what are some of the ways that people have tried to get around Arrow's theorem?
Well, one way is to restrict the domain of admissible preferences. So instead of saying that the social welfare function has to work for any possible set of preferences, we could say that it only has to work for certain kinds of preferences.
Like what kind of preferences?
Well, one example is single-peaked preferences.
Okay, I've heard of that. What does that mean again?
So single-peaked preferences basically mean that you can order the options along a single dimension, and everybody has an ideal point on that dimension.
Okay, so like if we're talking about political ideology, you could order the options from left to right.
Right. And everybody has like their ideal point on that spectrum. And then as you move away from their ideal point in either direction, their preferences go down.
Okay, so like I might be a moderate and my ideal point is right in the middle. And then as you move further to the left or the right, I like the options less and less.
Exactly. And if everybody has single-peaked preferences, then you can actually prove that majority rule will always produce a transitive social preference.
Oh, really? So like Condorcet's paradox doesn't apply if everybody has single peak preferences.
Right.
So like maybe part of the problem isn't majority rule itself, but the fact that people's preferences aren't always nicely ordered like that.
Yeah, I think that's a plausible interpretation.
Mm.
And it raises some interesting questions about like how we can encourage people to have more single-peaked preferences.
Yeah, like maybe through deliberation or education or something like that.
Right.
Okay, so that's one way to get around Arrow's theorem. What are some other ways?
Well, another way is to relax the ordering condition. So instead of saying that the social preference has to be completely transitive, we could say that it just has to be quasi-transitive.
Quasi-transitive? What's that?
So quasi-transitive means that if A is strictly preferred to B and B is strictly preferred to C, then A has to be at least weakly preferred to C.
Okay, so it's like you can have ties, but you can't have cycles.
Right. And if you relax the ordering condition to allow for quasi-transitivity, then you can actually get some more social welfare functions that satisfy the other conditions.
Okay, so like maybe we don't need perfect transitivity. Maybe it's enough to just rule out cycles.
Right. And there are other ways to relax the ordering condition as well. Like you could say that the social preference only has to be a partial order.
Which means what?
Which means that it doesn't have to rank every pair of options.
Okay, so like maybe we can just say that the group prefers A to B and that's it. We don't have to say how A compares to C or how B compares to C.
Right.
Okay, so those are ways to relax the ordering condition. What about the other conditions?
Well, you could also relax the weak Pareto principle.
Really? But that one seems pretty fundamental, right? Like if everybody agrees on something, then the group should agree on it too.
Yeah, it does seem pretty basic. But there are some philosophical arguments for relaxing it. Like, for example, if everybody agrees on something that's based on false information, then maybe the group shouldn't agree on it.
Okay, so like if everybody thinks the Earth is flat, then maybe we shouldn't just go along with that.
Right. But I think in general, most social choice theorists are pretty hesitant to relax the weak Pareto principle because it leads to some pretty counterintuitive results.
Like what?
Well, for example, you could end up with a situation where there's a dictator, but it's an inverse dictator.
An inverse dictator, what's that?
It's like a regular dictator, but their preferences are always the opposite of what the group chooses.
Oh, wow. So like whatever the dictator wants, the group always does the opposite?
Right.
That's pretty weird.
Yeah.
Okay, so relaxing the weak Pareto principle seems kind of risky. What about independence of irrelevant alternatives?
That's another one that people have tried to relax, and I think there were some good philosophical arguments for doing so.
Like what?
Well, for example, one of the problems with IIA is that it can lead to situations where the winner of an election is someone who would lose to every other candidate in a head-to-head matchup.
Really? How's that possible?
Well, it's because of the way that plurality voting works. So let's say we have three candidates, A, B, and C. And let's say that 40% of the population prefers A, 35% prefers B, and 25% prefers C.
Okay, so A wins because they have the most votes.
Right. But now let's say we have a head-to-head matchup between A and B.
Well, B would win because they would get the 25% of the vote that went to C.
Right. And the same thing would happen if we had a head-to-head matchup between A and C.
So A wins the election, but they would lose to every other candidate in a head-to-head matchup.
Right. And that's because of IIA. Because IIA says that the social preference between A and B should only depend on people's preferences between A and B. It shouldn't depend on how people feel about C.
Okay, so IIA can lead to some pretty weird results.
Yeah. And there are other problems with IIA as well. Like, for example, it can make it hard to design voting systems that are resistant to strategic voting.
Strategic voting, what's that?
It's when people vote in a way that doesn't reflect their true preferences in order to try to manipulate the outcome of the election.
Oh, right. Like if I know that my favorite candidate has no chance of winning, I might vote for my second favorite candidate instead, just to try to prevent my least favorite candidate from winning.
Exactly. And IIA can make it really easy to manipulate elections in that way.
Okay, so relaxing IIA might be a good idea, but what are the downsides?
Well, the main downside is that it can make this social preference less stable. So, like, if we relax IIA, then the social preference between A and B might depend on how people feel about C. And that means that the social preference can change even if nobody changes their mind about A and B.
Oh, I see. So, like, if we introduce a new candidate into the race, it could change the outcome, even if nobody changes their mind about the original candidates.
Right.
Okay, so relaxing IIA is kind of a trade-off. We might get a more fair and representative outcome, but we might also make the outcome more unstable.
Right.
Okay. So we've talked about ways to relax the different conditions of Arrow's theorem. But I think there's another way to get around the theorem that we haven't discussed yet.
What's that?
Well, it's to change the way we think about preferences.
Okay. How do you mean?
Well, so far we've been talking about preferences as if they're just rankings.
Right.
But what if preferences are more than just rankings? What if they also have intensities?
Ah, I see. Yeah, that's a good point. So, like, maybe I prefer A to B by a lot, but I only prefer B to C by a little bit.
Right. And if we can incorporate those intensities into our social welfare function, then maybe we can get around Arrow's theorem.
Yeah, that's a possibility. And in fact, there are some social welfare functions that do take intensities into account.
Right.
Like, for example, the board account.
Oh, right. The board account. We talked about that earlier.
Yeah. So the board account assigns points to each candidate based on their ranking, and the candidate with the most points wins.
Right. And that system takes intensities into account because the higher a candidate is ranked, the more points they get.
Right, but the board account still violates IIA.
Oh, right. We talked about that earlier, too.
Yeah, so it's not a perfect solution. But it does show that if we can incorporate intensities into our social welfare function, then we can at least get closer to satisfying all of Arrow's conditions.
Okay. So maybe the key to getting around Arrow's theorem is to think about preferences in a more sophisticated way.
Yeah, I think that's a plausible conclusion.
Yeah.
And it opens up a lot of interesting philosophical questions about the nature of preferences and how we should measure them.
Definitely. Okay, so we've talked a lot about preference aggregation, but I think there's another really important aspect of social choice theory that we haven't discussed yet.
What's that?
It's strategic voting.
Ah, yes. That's a crucial one.
Yeah, because even if we can come up with a social welfare function that satisfies all of Arrow's conditions, there's still the problem that people might not vote, honestly.
Right. People might try to game the system by voting strategically.
Exactly. So, like, if I know that my favorite candidate has no chance of winning, I might vote for my second favorite candidate instead, just to try to prevent my least favorite candidate from winning.
Right. That's a classic example of strategic voting. And it's a really big problem for social choice theory because it means that the outcome of an election might not actually reflect the true preferences of the voters.
Right, because people are voting based on what they think is going to happen rather than what they actually want.
Exactly. And there's a really famous theorem in social choice theory called the Gibbard-Satterthwaite theorem that basically says that any voting system that's not dictatorial is going to be susceptible to strategic voting.
Oh, wow. So, like, there's no way to design a voting system that's both fair and immune to strategic voting.
That's essentially what the Gibbard-Satterthwaite theorem says.
Which is, like, really disheartening.
Yeah, it's definitely a pessimistic result.
Mm-hmm.
But I think there are a few things to keep in mind. First, the Gibbard-Satterthwaite theorem only applies to voting systems that are deterministic. So if we allow for randomized voting systems, then we might be able to get around the theorem.
Randomized voting systems, what are those?
They're voting systems where the outcome of the election is determined by a random process.
Oh, okay. So, like, instead of just counting the votes and seeing who gets the most, we could flip a coin or something.
Yeah, something like that. And there's some evidence that randomized voting systems might be more resistant to strategic voting.
Interesting. Okay, so that's one way to get around the Gibbard-Satterthwaite theorem. What are some other ways?
Well, another way is to restrict the domain of admissible preferences.
Oh, right. We talked about that earlier in the context of Arrow's theorem.
Yeah, so, like, if we restrict the domain of preferences to single peach preferences, then we can actually design voting systems that are strategy-proof.
Oh, really? So, like, maybe if we can encourage people to have more single-peaked preferences, then we can make our voting systems more resistant to strategic voting.
Yeah, I think that's a possibility.
Okay, so those are some ways to get around the Gibbard-Satterthwaite theorem, but I think there's also another important point to keep in mind, which is that strategic voting isn't always a bad thing.
Oh, how do you mean?
Well, sometimes strategic voting can actually lead to a more fair and representative outcome. Like, for example, if there are two candidates who are very similar, and I prefer one of them slightly more than the other, then it might make sense for me to vote strategically for my second choice just to make sure that one of them wins.
Ah, I see. So strategic voting can be a way for voters to express their preferences more effectively, especially when the options are very close together.
Right. And it can also be a way for voters to coordinate their actions to achieve a better outcome.
Yeah, that's true. So, like, if I know that a lot of other people are going to vote strategically for a certain candidate, then it might make sense for me to do the same, even if that candidate isn't my absolute favorite.
Right. So strategic voting can be a way for voters to achieve a kind of collective rationality.
Yeah, I think that's a good way to put it. So, it's not always a bad thing, but it's definitely something that we need to be aware of when we're designing voting systems.
Okay. So we've talked about preference aggregation, Arrow's theorem, the Gibbard-Satterthwaite theorem, and strategic voting. I think we've covered a lot of ground here.
We have. Social choice theory is a rich and fascinating field.
It is. And I think it's a really important field for philosophers to be aware of because it raises a lot of deep questions about the nature of rationality, democracy, and collective decision-making.
Absolutely. And I think it's a field that's only going to become more important in the future as we face increasingly complex social and political challenges.
Yeah, I think you're right. Okay, well, I think that's a good place to end our deep dive for today.
It has been a great discussion.
Yeah, I learned a lot. Thanks for joining me.
My pleasure.
And to our listeners, thanks for tuning in. And be sure to check out the Stanford Encyclopedia of Philosophy entry on social choice theory if you want to learn more about this fascinating topic.
Definitely a great resource.
Okay, until next time, keep on diving deep.